So building software involves a lot of things per se to go right. And if you think about trying to build something that is big, right? Software like Microsoft Windows, or the operating system that runs on your phone, or anything that is worthwhile, even not at that scale, but software that works, so an application, for instance, there are a lot of things that have to happen in our code. There's a lot of compartmentalized pieces of code that need to happen and work together so that we can have an application, for instance. So it is important to find ways in which we can have code snippets, or in this case, entities of codes that by themselves they can do something, and they can also interact with other parts of your code. So this is the basic concept of object-oriented programming. The object-oriented programmer, or OOP, relies mostly on creating these entities called objects that by themselves they can live, but they can also interact with other objects in a bigger system, in this case in our application. So let's start small. What is an object? Now if we think of a car contains a lot of different pieces, if you will, for it to be a car. So it has an engine. Inside of this engine we have other things, of course. It has wheels, we have brake system, the car has electric system, and so forth. So in a bigger picture, that is what a car is really, right? Is a collection of different little systems that when working together they become a car that you and I can drive. But we have to understand even deeper. If we take a step back, if we look at a car in this case, if we think conceptually what a car has to have some sort of properties. So a property would be, for instance, attributes or fields, right? Those would be the characteristics of the car. This is more of the outside view of what a car is. For a car, for instance, could have a color, could have a model, a year, and so forth. And then we have what a car does. So these would be the behavior. So a car could start, a car could start driving, a car can accelerate, can decelerate, can brake, and all these things. Conceptually, before we have an actual car, we have to have some sort of a map that will dictate what the actual car would look like and what it would do. So in object-oriented programming, this would be a class. So a class essentially is a map or a blueprint of an object. So in this case, we have a plan, which is a class, that then we can instantiate that into an object, which will be the actual car. So it is important to have classes which in turn are instantiated into objects, because then we can build these entities, in this case these objects, that can interact with other objects to create a bigger system, to create a bigger application, and go from there. Now you notice here, depending on which programming language you're coming from, or and attributes, property, fields is the same thing. Behavior, functions, methods is the same thing. So essentially what we're talking about when we talk about behavior, functions, or method, we're talking about what the car does, as I explained before. And attributes, property, fields are the characteristics of the car. Okay, let's go back to our code so we can see how can we create a class in Kotlin and instantiate it to create an actual object. Okay, so back to our code here. We're going to go outside of our function, okay, because we're going to create a class. All you say is you say class, and there it is. Say class, and we're going to give it a name. So classes follow a certain naming convention, that means they have to have an uppercase first letter. So in this case, let's say car, and then we create curly braces like that. As a class, this is not an object yet, so we need to actually create the map, the blueprint, the plan of what a car in the real world, in this case when it becomes an object, when we instantiate it, what properties and methods will have, right? So let's go and define a property. I'm going to say val, and they're going to say color, and it's going to be a string type, and as we know, we need to initialize with something. It's going to be red. Now how do we instantiate this class into an object to actually use it? Well, we go up in main. I'm going to say val, let's just say car is equal to car, like this, and put parentheses like that. So now we have our car object. This is the actual object we've created. So I can go ahead and say print, for instance, and say car dot color. So I have car dot is the accessor operator here. So we're accessing something from our car object. Color. And what do you think it's going to print? Let's see. Let's go ahead and run. And red. Because we set the color property of this car in our class to red. And I can set another property, say val model. It's also going to be a string. I'm going to set that to xmd, something like that. I don't even know what that is. It's okay. So I can do the same thing, right? Now print here, once we've instantiated the object, I'm going to say model. Actually, I should say car.model. If you run, you can see xmd as the model of the car. Very good. So we have created a class. It's very simple. Say class and the name of the class. And of course, we have curly braces to say, okay, now we're going to start the body of the class. So we have our properties, or fields, or attributes, okay? Same thing. Now let's go ahead and give some behavior, some function, right? What this car does or can do. I'm going to say fun. There we go. I'm going to say drive. Well, this car must drive. So what we want to happen when we drive? Well, for now, I'm going to say print ln like this and say drive. So if I come here, I say car.drive. I'm invoking the drive method, function in this case, which is a behavior of this car. So a car has these properties and has this behavior, which is to drive, what a car can do. If I run this, we're going to see drive vroom. Now, we have a problem here. The problem is that, well, we can't really change the properties, which is not very exciting because we want to be able to change our properties of our class, our object. So how do we do that? Well, first of all, we need to change the val to var. You remember this. Val is immutable. Var is mutable. So I'm going to say var like this. Now I can come up here, right after where we instantiated, we create the actual object of car. There, I can say car dot color. I can now set this to something different. Blue. I can say car dot model. I can set this to MDF like that. If I run this, you will see, because we're overriding what we have set before, we're going to get something different. This says drive. Of course, it's going to be different. Let's go ahead and print actually something real nice here that says color like that, model. This will be better. Let's go ahead and run. Okay, so car color, blue, model, MDF. There we go. So now it's way better. Notice, like I said, because we changed this to var, the properties, we can now access those and edit those or mutate those, change those, which is very exciting. And we can still, of course, invoke drive if we want to.